This is a short film describing the history of the tests and evaluations conducted by the Houston pilots in support of safe navigation access to the Houston Bayport Container Terminal. All tests and evaluations have consistently determined that dredging of the Bayport Channel and flare is essential for navigation safety. The Bayport Channel was enlarged in the early 1970s to 300 feet wide and 40 foot deep to support medium-range chemical tankers of approximately 600 foot in length by 90 foot of beam with 36 feet maximum draft. In 2004, the Houston pilots began discussions with the Port of Houston regarding the widening of the Bayport approach, flare, and cut channel. Shortly thereafter, Phase 1 of the Bayport Container Terminal was completed. The pilots instituted the Bayport Guidelines with maximum permitted size vessels set at 965 feet length overall and 106 feet of beam. 6 years later, in 2011, discussions were again held with the PHA staff regarding widening of the Bayport Channel and flare. At the same time, it was decided by the Houston pilots to conduct research at the U.S. Army Corps of Engineers facility in Vicksburg, Mississippi, to determine the best plan for safe navigation access to Bayport Container Terminal. This research by the pilots determined that a channel easement on the right side of the flare entrance, along with a redesign of the flare to a 4,000-foot radius, would provide the best overall improvement to navigation safety. Shortly thereafter, a consortium of the Houston pilots and the Port of Houston Authority employed Dr. Larry Daggett of Waterways Simulation Incorporated to conduct additional studies using the MyTag simulation facility in Baltimore, Maryland. This study, using the identified Bayport flare and channel widening profiles, identified that wind speeds in excess of 20 knots made controlling post-Panamax vessels difficult and unsafe. The study also identified that the existing channel, without dredged improvements to the flare and channel, was unsafe for post-Panamax container ships. It was clear to all that the new Panama Canal locks were going to provide in the Gulf region giant Neo-Panamax vessels of 14,000 TEU and 1,200 foot length overall. Knowing that the Bayport Container Terminal cranes were capable of servicing the new Neo-Panamax vessels, it was decided by the pilots to physically construct the Bayport Channel and flare at scale, with proposed dredge improvements, and to construct a scaled Neo-Panamax vessel to validate the wind and maneuvering limitations being consistently found in the ship simulators. The scaled Neo-Panamax ship model and the scaled Bayport waterway are complete, and extensive testing has been conducted in this waterway with the new model vessel. The maneuvering difficulties found in the ship simulators have also been found in the scale model. The vessel has extreme sensitivity to wind forces and requires over 4 large tugs to maneuver in winds over 20 knots, and can become uncontrollable in winds over 30 knots. In this typical example from the model testing at the Maritime Pilots Institute, the model is proceeding inbound to Bayport in the existing channel, and the vessel is unable to maneuver into Bayport, ending up aground in the Bayport Channel. The vessel was maneuvered in a conservative fashion by the pilot, but since the vessel's stern was unable to swing to the east into the proposed widener, the turn was started late, and the vessel could not turn fast enough to make it into the channel. Going faster in an effort to make the ship turn faster only causes the ship to squat down to the bottom, further impairing her turn. Using the tugs to assist is possible, but they lack the room in the existing channel to work properly around the ship in the channel. Thus, the channel is too tight for this ship to consistently make safe turns in and out of Bayport. Overall, the model testing demonstrates that the maneuvers in the Bayport area are difficult and unsafe without the proposed dredging improvements to the channel, eastern widener, and the flare radius 4,000-foot profile. This concludes our review of the research history and current efforts by the Houston pilots and our many research partners and stakeholders supporting safe navigation access into Bayport. We feel the research is compelling and consistently indicates a need for dredging in the flare and channel areas. We thank you for your attention to this important issue as we pledge to continue our investment and support for the success of the Bayport Container Terminal.